centuries, the River Towy must have looked much like this, flowing strongly from the mountains of central Wales southwards to the Bristol Channel. The Towy has changed little over the centuries, but man's needs have. Today, water is precious and scarce. We can no longer allow it to pour away, largely unused, into the sea. The Towy must be controlled. Increasing industrial demand in the supply area of the West Glamorgan Waterboard has created problems in times of drought. The board's consulting engineers have recommended that the Towy and its catchment area can solve these problems for many years to come. What is needed is a reservoir up in the mountains near the source of the river, where the rainfall is heaviest, 2,000 millimeters a year. The new lake will then regulate and augment the flow of the Towy. Water will be taken from the river 64 kilometers downstream and pumped to a new treatment plant and control centre near Swansea. From there, it can be distributed through the board's existing supply system. The biggest job in the scheme will be the construction of the dam at Llyn Brianne. The site is in a narrow gorge. The rock is exposed or near the surface. Studies by the consultants have shown that a rock-filled dam with a clay core will be less costly to build than one of concrete. 4.5 years have been allowed for its completion, but the contractors are aiming to impound the river after only 3.5 years. Standing over 90 meters, Brianne Dam will be Britain's highest, and the length along its crest will be 300 meters. 5.5 million tons of material have to be placed in this gorge. While this is being done, the Towy will have to be diverted through a tunnel some 430 meters long. A coffer dam will be needed to divert the river into the tunnel and to keep the gorge dry. Other underground works will be needed in the project, principally a draw-off tunnel and shaft to lead water from the reservoir to the permanent outlet works at the downstream end of the tunnel. There will be an overflow spillway, as well as new roads and bridges to the regulator house and across the dam crest. A quarry area at the spillway approach will provide the rock fill for the dam. First, the Towy must be diverted. The downstream end of the tunnel has to be extended in cut and cover to carry the river well clear of the toe of the dam. The tunnel is lined with concrete. All major tunnelling work must take place during the first year on the site, the year of preparation. And already, Llyn Brianne is living up to its reputation for high rainfall. The tunnel is ready to take the Towy. Upstream, the material removed forms the first part of the coffer dam. And all the time, the river must be kept free of pollution and available to the users downstream. Work has been going on for 12 months. Already 300,000 cubic meters of loose material have been removed from the river valley. But not until the riverbed is dry can the cleanup and grouting be finished. The next 2 years of the schedule will be the years of building the dam itself. The rock is largely a slaty mudstone. Foundation work has uncovered a channel cut by Ice Age water. This must be cleaned out and filled with concrete. On the steep valley sides, the abutments have to be cleared of loose rock, while the area which will be in contact with the clay core has to be excavated down to solid rock and then sprayed with concrete. Rock will form the bulk of the dam, 4.5 million tons of it. All to be won from the quarry area, up to 16 tons at a bite. The rock is hauled to the dam by a fleet of rear dump trucks, each with a 45-ton payload, running day and night over a system of temporary roads designed to serve each level of the dam as it rises above the valley floor. Only 11 kilometers away, near Abergwesin, is the source of clay for the dam. Its availability was a key factor in deciding the kind of dam which would be built. The clay will form the dam's impervious core. Once sheep drovers passed this way, taking their flocks to the markets of London. Now the roads are new, and so is the flock. 25 tipper trucks carrying a regular supply of clay for the dam builders. A cross-section shows the composition of the dam. Upstream, the coffer dam protects the site and diverts the river into the tunnel. Curtain and blanket grout will prevent water from seeping through below the core. The core itself is of impervious boulder clay, of low plasticity, and with a high stone content. It is protected from erosion downstream by a filter zone of fine material. Beyond this is transition material of clean rock, while there is a drain of larger rock in the old riverbed. To protect the upstream face of the core, there is another transition zone. The shoulders of the dam are rockfill. Downstream, a stepped slope gives an average gradient of 1 on 1.75. While upstream, the slope is 1 on 2. Much of the graded transition material is produced by a crusher on the site from rock dug selectively in the quarry. The fine filter material is obtained from an old lead mine at nearby Llandovery, a new use for an old waste product. One of the most difficult jobs. To make room for the spillway, half a mountain must be cut away, over 1 million tons of rock. clay core is compacted in 0.3 meter layers by 4 passes of a vibrating roller. At the abutments, particular care must be taken, and here smaller manual equipment is used. And all the time tests are carried out. This one confirms the compacted density of the clay core. Late autumn in the second year of the project, but the first year for placing rock and clay. Progress is good. The chances of impounding at the end of the third year get better and better. And that means the people of West Glamorgan will get their much-needed new water supply a whole 12 months earlier than originally expected. Still more tests, this time by the building research station, keeping an eye open for any movement which might occur in the structure.
2, 5, 8, 7...
Excavation has now moved to the top of the spillway, cutting the approach channel and providing more and more rock for the dam. Fill is spread in layers 0.45 meters thick. After 2 layers have been spread, they are compacted. And all the time, the various zones of the dam must keep pace with each other as they rise above the valley floor. In carrying rock and clay to the site, the trucks are traveling huge distances. By the end of construction, they will have covered 2 million kilometers. Spring of the third year, and concreting starts on the spillway. The slope is 1 on 1.8 at its steepest. For the men who will work on the spillway, the months of building will make huge demands on their stamina. The water which will flow down the spillway will reach a velocity of up to 27 meters a second. This energy must be dispersed by a break of slope at the bottom, the spillway bucket. Stresses within the dam are monitored by settlement gauges and groups of piezometers set at 3 different levels. The settlement gauges are connected by plastic tubes to observation stations on the downstream face. The tubes from the piezometers run in precast channels down to the gauge house near the tunnel outlet. Here, the pore water pressure can be measured. High pressure is the danger. It can cause instability in the structure. This tube contains a pneumatically powered induction instrument to detect any horizontal movement within the dam. Horizontal movement, too, is measured by inclinometers, let down into the dam inside metal tubes. The tubes are built up vertically through the clay core from the riverbed to the summit. This is done along the center line of the dam at 3 places. This batching plant provides concrete for the spillway. The mix has had to be specially designed for the job and needs an aggregate whose nearest source is 100 kilometers away. The need for the special mix is because of the steepness of the hillside. The concrete has to be pumped over a length of 350 meters, with a maximum fall of 100 meters below the batching plant. This is the longest vertical distance concrete has ever been pumped in Britain, and there are over 20,000 cubic meters to be placed. The end of the third summer, the second of placing rock and clay. The dam is nearing its summit, becoming a more difficult and congested work area as the crest narrows. Only a few more meters to reach the top. Good progress on the spillway. The crest has been excavated, though it will be the last part to be concreted. Further down, the concreting is well advanced. The high-quality finish will be produced by drag screeds, which, like the travelling wall shutters, have to be secured on cables attached to winches on the crest. Sometimes the men on the spillway wish they were on winches too. And the rain doesn't help. Winter means special concreting techniques to get the spillway ready in time. But the job is nearly completed. Concreting has moved right to the foot of the slope, to the spillway bucket. The main structure of the dam at Llyn Brianne is finished. Impounding can start. This is the upstream face of the dam. The draw-off tunnel and gate shaft are ready, but the river still flows through the main tunnel below. Before this tunnel is sealed, an emergency gate must be lowered into the draw-off shaft, and so prevent the rising waters of the reservoir entering it. Now the stop-lock gate can be placed at the entrance to the diversion tunnel, and the tunnel itself sealed. It will then be dry, and work on the outlet can be completed. But as the man-made lake fills, a guaranteed flow of water must still be maintained through a permanent scour pipe. While the reservoir fills, the tunnel will be permanently plugged with concrete. At the downstream end, the delivery pipes from the draw-off tunnel and shaft can be installed. The regulator house and valve systems will also be finished. The water will continue to rise during the summer, and less than a year after impounding, water will be able to flow over the spillway crest and safely downstream. Then, when all the tunnel works are completed, the emergency gate can be lifted. It will be left raised but ready to be used if needed at any time. 3 permanent discharges will be available through the scour pipe, through the draw-off tunnel, shaft and draw-off system, and in times of flood, over the spillway. The third year of the project ends. Now come the months of finishing and of impounding. Upstream, bulldozers reduce the river flow while impounding operations go ahead. The precast units of the concrete trash racks are placed. A steel screen is fixed at the entrance to the draw-up tunnel. The stop-lock gate is lowered on its supporting towers, sealing the tunnel entrance. Three years ago, this was a remote country valley. Soon it will be a growing reservoir. 215 hectares of the valley, in my language about 525 acres, have been cleared of trees, but otherwise only sheep have been moved. Not a single farm will... The people who have helped to build it can relax in a chat with Her Royal Highness Princess Alexandra, bask in the Welsh sunshine and the knowledge of a job well done. The board's control centre at Llyn near Swansea regulates the flow of water from the new lake. At the push of a button, whenever necessary, a radio signal is transmitted and more water is automatically released at Llyn Brianne. Water flows down the Towie Valley at a controlled rate. 400,000 people in the Swansea area are now benefiting. Almost 400,000 cubic meters a day are available. All this has been achieved a whole year ahead of schedule, thanks to the speed with which the Llyn Brianne Dam was built, and the river's environment is unscarred. Caredig pumping station, 64 kilometers downstream from Llyn Brianne. Here water is pumped from the Towie into settling tanks. Water for people. Water for commerce and industry. Water for Wales.